Perfect. Cool. So, that's weird. Okay. In any case, okay. So let's talk through the idea of scope. Scope is fairly tricky in the sense that it will always be there no matter whether or not you want it to be. So yesterday we talked about something like coercion, right? It's like, well, if I want to use a number data type, I have the option of using a number data type. I could choose not to use other data types if I want to, right? So with a lot of things we teach you, there is this possibility of, hey, maybe I can avoid using it if I'm less comfortable with it. With the idea of scope, there's really no way around it. And so it is something that you will, unfortunately or fortunately, kind of need to really get comfortable around going forward. So today's lecture will be fairly short. We talk about what is scope, and we'll be talking about three types of scope. There are more, but these are kind of the main ones. There's global scope, there's functional scope, and there's block scope. We'll do a little bit of a quick, one slide primer on functions and hoisting, and then we'll just give you some tips on scope best practices. So what is scope? I like to think of scope essentially as a sandbox or as a perimeter around which certain variables in your code can be accessed and other variables can't, right? So if you think about a sandbox, it's a pretty clear border. If I have a toy that belongs in the sandbox, then I really only want to use it or play with it while I'm in the sandbox. If I'm outside of the sandbox, then to kind of carry this analogy a little bit further, it means I really shouldn't be using, or I really can't be using things inside the sandbox. So what do we mean when we say the sandbox, or what do we mean when we say scope? It's actually something that you've already seen before. More specifically, it has to do with the curly braces that we use to define both objects, but more so functions and loops, right? So one quick example that kind of gives a really quick idea of maybe how to start thinking about scope is on line 4 here. We have a variable called wow, and when we console log it out, we see the string wow. So that's pretty clear. What's happening behind the scenes here is actually a little bit more complicated than maybe us just creating a variable and us using it. And today we're going to talk through why that variable can be used here and what are the scenarios in which that variable may not be able to be used here. So let's take a look at firstly the most broad form of scope, which is a global scope. A global scope basically just means that this variable is accessible to anyone, anywhere on your page or in your big block of code. It can be referenced from anywhere, and the value assigned to the variable cannot be accessed until the assignment operation occurs. So that second part has a little bit more to do with this idea of hoisting, which we'll talk about later on today. But for now, let's just focus on the very first part, which is that a global variable can be referenced from anywhere in your code. So here, if I look at lines 5, 7, and 9, I on line 5, I'm dropping a console log, but I'm using a variable that has not quote unquote been created yet when it gets to that line of code. It uses the variable called wait for it, but I actually create the variable wait for it until I get to line 7, or I don't create it until I get to line 7, and then on line 9 I console log out wait for it. One of the things that we want to kind of really drive into in terms of making sure that you're clear on this idea of global scope is simply that when we think about variable placement, the global scope is the outermost layer. If I think of writing my code on a piece of paper, if I put something on the global scope, then it means there's no container around it, or rather everyone can use this variable. Here in this example, notice how even though for my variable wait for it, even though on line 5 I'm attempting to use it, I don't actually quite get access to the value yet until I use that assignment operator on line 7, right? That equal sign, which is the assignment operator. We're going to talk a little bit more about hoisting going on, but for now, just know that when I have a variable that has no curly braces around it, or rather it's not created or contained within a curly brace, then it's a global variable, and it means anybody anywhere on this page has access to this variable. The contrast of that would be something like a functional scope. And so this is kind of hopefully where the idea of scope makes a lot more sense. Variables declared inside of a function are what we call locally scoped, which means that they are able to be used within the scope or within the function that they're in, the function scope that they're in, but they cannot be used outside of that function. So let's take a look at an example of that. Here on line 5, I create a function called happy function, and in it on line 6, I create this variable called message. On line 7, I console log out message, and on line 10, I invoke the happy function. Now, on line 11, I also try to console log out the variable message. Theoretically, based on what we've seen so far, this should be fine, right? Because on line 5 through 8, I've created the parameters for this function, and on line 10, I actually run this function. So when I run this function after line 10, I should have created a message variable. So on line 7, when I console log out message, it should print out I am so happy. And when I console log out message on line 11, it should also console log out I am so happy. But when we do it, in reality, what actually happens is on line 7, that console log works perfectly fine. And you see it on the top right-hand corner of your screen. You see us printing out I am so happy. But for the variable message on line 11, we actually get a reference error. And the reason for that is because essentially, because we created the variable message on line 6 within the scope of the happy function, that means that we are only able to access and use that variable within that function. AKA, we could only use it within or between lines 5 through 8. On line 7, when we console log out message, that's totally fine because on line 7, when we see the variable message, what we're saying is, okay, great. Here, let's use this variable message, and it was created on line 6. And more importantly, on line 7, we have access to the variable that we created on line 6 because both line 6 and line 7 are in the same function as defined by the curly braces on lines 5 through 8. When we get to line 11 and we try using the variable message, well, we basically cannot use variables declared inside of a function unless we are also inside that function. In this case, on line 11, the console log is not inside happy function. And so if we put ourselves in the perspective of the console log on line 11, everything inside happy function is essentially a black box. We don't know what's inside of it, and so we don't know that there's a variable called message inside of it. And so if we put ourselves in the shoes of the console log on line 11 and we try to access a variable called message and we can't find it because we can't look inside lines 5 through 8 and the variable message isn't anywhere else, well, then we see the error that we talked about on day 1, which is a reference error, or rather something that tells us, hey, the variable that you're trying to use here called message, I can't find it. It doesn't exist. And so here, like once again, just to kind of reiterate this point here, on lines 5 through 8, because we're creating a function, we are inherently also creating a function scope, which means like the borders of a function. And therefore, once again, any variables we create inside that function can be used only inside that function, and only other lines of code inside that function can use that variable. Once we leave that set of curly braces, aka in this case, once we go outside of lines 5 through 8, we no longer have access to the variables that we've created inside the function. Does that make sense to folks? Or rather, are there any questions? Oh, sorry, I see someone wrote down a question here. Let me How would you explain global scope in the sandbox analogy, a toy that can be used inside and outside of it? That's actually a really good way of thinking about it, Carlos. Thanks for asking. Yeah, a global variable essentially is like something that can be used both inside the sandbox and outside of the sandbox. One analogy that we can also use if you want to think about it a little more granularly is sorry, I thought I had to sneeze there. When we think about each function scope, you can think of it as almost like a sandbox inside of a sandbox. Right? So you can think about like a hotel would be one example, right? If I'm a patron in a hotel and I walk into the hotel, there are a lot of public things that I can use, right? But then when I walk into my room, there are only things in the room that only I can use, right? The other guests cannot use. And so you can think of global, if you think of your big sheet of paper or your big block of code as a hotel, well, maybe the global the global variables could be like the concierge, right, or like a vending machine. Whereas the variables you create inside of a global, or rather the variables you create inside of functions inside of the global scope could be like your like the bathroom in your hotel room, right? Like only you have access to that, no one else can. Um, I don't know if that's necessarily the best analogy, but it is one way to when we write code to think about who has access to what. Does that clarify it a little bit? Cool, awesome. So one other thing to just kind of before we even go any further in when we talk about scope is just to understand why there is scope. The reason why scope is really a big deal in programming is because scope really helps us reinforce the idea of safety, right? Just like how, if you go back to our hotel analogy, we don't want everyone to have access to everything at all times, right? It's just very unsafe. Think of yourself writing a program in which you're dealing with someone's username or password or email or even social security number, right? Like you can think of how dangerous it is to have anyone in the code have access to anyone's data everywhere else. Generally speaking, when you write code, you want to keep things as compartmentalized as possible, and you want each piece of code to only know as much as it needs to do its job or its function. And so when we think about scoping is actually one way for us to kind of set those parameters, set those boundaries to make sure that who knows what, and also to ensure that certain functions don't have access to other pieces of information or data that it shouldn't have. So so if we think about, so now we're going to go into one situation that actually happens quite often, which is what if we have the same variable that exists in two places? It's both a global variable as well as a local variable. So here on line 3, we have this variable called message, and we assign it the string sync globally. On line 5 through 10, we create a function called log a message. On line 6, we create another variable called message, and then on line 9, we console log out message. What's going to happen when we invoke log a message? Well, on line 9, when we actually console log out message, this is another behavior that JavaScript has with regards to scope and kind of handling these variable collisions. In general, what a line of code will do is whenever it encounters itself using a variable, it will always look to see if that variable exists in its own scope first. Okay, and so in this case, the message variable exists in the login message scope because we're invoking it from line 9. The function scope for line 9 is lines 5 through 10, and so it's going to look for the variable message inside of that scope first. If it finds it, then it will use it, right? It won't look any further. But if it doesn't find it, then it will go outwards one more layer, which in this case happens to include line 3. In this case, it won't matter to us because once again, on line 9, when we console log out message, we find message in our own local scope first, which is created on line 6, and therefore that's the variable that we use. But if, let's say, message wasn't created, let's say here, it's the same code as before, except now on line 6, rather than creating a variable message, we create the variable MSG. Now on line 10, when we console log out message out to the group, what's going to happen is it's going to look inside its own scope, i.e. lines 5 through 11, for the variable message first. And it's not going to find it because we never created a variable message in the login message function. So then it will look outwards one layer, and when it does, it will look on the global scope for the variable message, and it will find it on line 3. And so at that point, it will say, great, let me use that variation of message, and when a console logs it out, it will print out the string think globally. Any questions on that? It's this idea that whenever a line of code in JavaScript looks for a variable, it will always look in its own scope first. If it doesn't find it, it will look outwards one more scope, and it will look outwards one more scope, all the way until it gets to the global scope. If it gets all the way out to the global scope and it still doesn't find the variable, then it will throw the reference error that we saw earlier. Is this clear to everyone? Or rather, are there any questions around this? Okay, so keep it moving. So then one thing to just that people tend to sometimes forget, which is understandable, is that parameters are also variables as well, and so they're held, I guess, to the same restrictions that actual variables are as well. So what I mean here on line 3, we create a variable called message and we assign a thing globally. On line 5 now, we have a function called logs a message, and it takes in a parameter, and we call that parameter message. On line 6, all we do is console log out message, and on line 9, we invoke log a message, but now we pass in the string act locally. Well, now when we get to line 6 and we console log out message, once again, JavaScript is going to, or rather the console log is going to ask, is there a variable called message in my own scope first? In this case, my own scope is lines 5 through 7. Is there a variable message that I've created? And the answer is, yeah, there was. There was this parameter that you created on line 5 called message. And what's the value of message? Well, the value of message is whatever we invoked the log a message with on line 9. And in this case, we invoked it with the string act locally, and therefore that becomes the message variable that is being used on line 6. So once again, just to keep in mind, when your function takes in parameters, those parameters effectively are variables that are created within the scope of that function, and so you are able to use it and treat it, in very much the same way. And so one last kind of tidbit here with regards to functional scope is just, one thing I kind of hinted at earlier is that there is this idea of nesting scopes too, i.e. it's not just, hey, I have a function and then after the function it's a global variable. There can be multiple layers of functions containing other functions. So if we look at this, page here, on line 2, I create this variable called global var and set it equal to the string global. On lines 4 through 12, I have this function called outer. Inside the function, on line 5, I create this variable called outer var. On line 7 through 9, on line 7 through 10, I've actually created this other function called inner. And in the inner function, on line 8, I created this inner var. And then on line 9, I console log out the global var, the outer var, as well as the inner var. This can be quite confusing if this is your first time kind of really looking at a nested function. And hopefully you can also kind of see why indentation is super important now, right? Especially when we get to kind of more complex levels of function nesting. Because when you indent it properly, it becomes a lot easier for us to figure out kind of where one function is and kind of which function contains which one. So once again, here when I try to invoke that console log on line 9 there, when I look for the global var, essentially what JavaScript's going to do is JavaScript's going to say, okay, is there a variable called global var in my own scope first? I.e., is there a global var in the scope between line 7 through 10? Because that's the function that we're in. And the answer is no, there's not a variable called global var. So then it says, okay, great. Let me look in the next outermost scope, which we call the parent scope. And the parent scope says, okay, that's lines 4 through 12. Is there a variable called global var inside there? And the answer is still no. So then we go out one more layer, and now we've reached the global scope, and now JavaScript asks, is there a variable called global var? If there is, then we use it. If there's not, then we're going to throw back the reference error. And in this case, there is. It's the variable called global that we created on line 2. So that's what we use. And then we follow the same pattern for outer. We look in our own scope first, so lines 7 through 10 for outer. We don't find it. Then we go to lines 4 through 12. We look for the outer var variable, and we do find it, so we use that. And then lastly, we look in our own scope for the inner var first, and we find it on line 8, so we use that. And that's what ultimately gets printed out. Once again, one thing to just kind of be aware that when we have multiple collisions, the same exact concept we just talked about applies as well, right? We look in our own scope first, then we look into our parent scope, then we look in that parent scope, then we keep going on and on and on until essentially we reach the global scope. So in this case, it's the same exact layout as before, except now I've basically created this variable called collision several times. I created on line 2, I created on line 4, I've also created on line 7. Now on line 8, when I console log out collision, the first question becomes, okay, does my local scope, or does the function that I'm in have a variable called collision? And it does. We created on line 7, so when we console log it out, we see that the value of collision is inner. However, if line 7 wasn't there, then when we on line 7, when we console log out collision, we look at our own scope first. So line 6 through 8, we don't find it. We zoom out, we go to lines 4 through 10. We say, do you have a variable called collision? And the answer is, yep, we do. It's a parameter that was created on line 4. And so the value of collision is whatever the outer, quote unquote, outer function was invoked with on line 12. In this case, the outer function was invoked with the string outer, outer on line 12 there. And so that becomes our value of collision. And then if that also wasn't there, then we kind of go through our whole process. We look in the inner function, lines 6 through 8. We don't find this. We don't find the variable. We go through lines 4 through 10. We look for the variable. We don't find it. And then finally, we go to our global variable. We find the variable on line 2. It's called collision. It's set equal to the string global, and therefore we are able to invoke the outer function with the string outer. But it doesn't matter because the variable that we end up using is a global variable called collision that we create on line 2, and so we print it out, we see the string global. And so you can kind of think of this as a very kind of like it's confusing, but it's also a very straightforward process, right? The way the computer or the way that JavaScript actually goes through and looks for the variables. It always looks in its own scope first, then the next outermost, then the next outermost, and so on and so forth until it reaches the global scope. Note that inner functions can access the scope of its outer functions, aka its parent functions, but the opposite is not true. So what does that mean? Well, here on line 3, I create a function called outer. On line 4, I create a function called outer var. On line 6, I have my inner nested function. On line 7, I create an inner var. On line 8, I console log out outer var and inner var. I invoke inner on line 10. Now on line 11, I also console log out inner var, and I run all of this. And the first console log that gets hit is in line 8, right? Because I'm console logging out outer var and inner var. Outer var, it will look in the inner function scope, line 6 through 9. It won't find it, so then it will look outwards one layer to the outer function on lines 3 through 12, and it will find the outer var on line 4 over there. And so that prints out outer, and then the inner it finds on line 7. So that prints out perfectly fine. On line 11, when I try to console log out inner var, this goes back to the idea that we saw on one of our very, very first slides, right? Which is that once you're outside of a function, you don't have access to the variables made inside that function. The inner function has access to the variables created in the outer function because the inner function is inside the outer function. However, because the outer function is outside of the inner function, on line 11, when we look for inner var, we are essentially looking for the variable inner var between lines 3 through 12, but we can't see anything, or rather JavaScript doesn't let the outer function access anything between lines 6 through 9. So when JavaScript goes to look for inner var, it doesn't find it in the outer function. It looks on the global scope, it still doesn't find it, and so therefore it gives back a reference error saying, hey, the inner var variable does not exist, or we haven't defined it yet. And so once again, right, the idea of or rather the concept of scope is unidirectional. I can look at my scope, I can look outwards, I can look outwards and outwards and outwards. I can't look inwards. One other analogy that I've given that you can see if it works for you or not is this idea that if, let's say, I'm short on money, the first person I would go to borrow money from would be my parents, right? I would ask them for money. And if they don't have any money, then I would go to my grandparents and so on and so forth. I would kind of move up my quote-unquote family tree. However, if my parents needed money, they wouldn't come to me first, or if my grandparents needed money, they wouldn't come to me first. And so that's kind of like how I think about it in some cases, which is that this direction kind of only works outwards. You only go to your parents kind of for access to the variables. The parent functions don't have access to the variables created within the inner functions, or what we typically call the child functions. Is that clear to folks? Okay. So this one is just a quick kind of something to be careful about. It looks the same as the previous page, except we got rid of the extra console log statement. But on line 9 there, once again, just make sure to keep in mind that the parameters are also variables. And so when we look at line 9 there, when we console log out outer var, it looks inside the scope of the inner function first, so in between line 7 through 10. It looks for a variable called outer var, and it actually finds it on line 7, which is a parameter. Now, the variable of outer var is equal to whatever is passed in when we invoke the inner function on line, it looks like line 11 there. The only question is we didn't pass anything in. That, once again, just keep in mind, whenever we call a function but we expect an argument, we don't give it, it doesn't throw an error. It actually makes that variable, but it just assigns it the value of undefined. And so when we console log out outer var, inner var, we actually see that the inner var is the string inner. That's pretty clear based on line 8. But the outer var is actually undefined because on line 11, when we invoked inner there, we didn't pass anything in, and that nothing, quote unquote, becomes the value of the outer var parameter on line 7. So once again, just kind of keep in the back of your mind that parameters are also functions, and it becomes a place that we look at for variable values kind of in the same sequence. The last thing we'll talk about with regards to scope is the idea of block scope. So block scope are also defined by open and closed curly braces, except now instead of being written around functions, they get written usually around loops or if statements. And so here in this case, we have an if statement on lines 4 through 7. On line 5, I have a variable called block, and on line 6, if I try to access that variable block and I print it out, that's totally fine. But on line 9, if I try to access a variable block, I get the same error I saw before, right? Which is to say that because the variable block was made inside this if block scope on lines 4 through 7, anything outside of it does not have access to the variable. So that's why the console log on line 9 there throws a reference error, because when JavaScript looks for the block variable, it doesn't find it because it can't look inside lines 4 through 7, and there's no other variable called block. One of the questions that folks kind of ask is, well, why do we have what's the difference between var and let when it comes to making variables? And really, the one of the main differences, there's only a few, but the main one is just that the var variable ignores the block scope. And so what that means is that in this case, if in the if block, or if in the if block scope I create a variable called block, I use var instead of let, then whenever I'm outside of that if loop, I can still access the variable block. This is now kind of been regarded as not good practice, and so that's why you actually don't really see people use vars anymore. People primarily use let now, and so that just means that we universally respect both the block scope as well as the function scope. The last thing we'll talk about with regards to kind of more technical things is just that there's something called hoisting in JavaScript, and what that means is whenever a computer or whenever a JavaScript engine scans a piece of JavaScript, it actually reads through it twice, not just once. And the first time when it reads through it, all it does is it makes a list of all the things that exist on the page. Okay, so it kind of does like a quick tally, and it remembers like, hey, this variable exists, this function exists, so on and so forth. On the second read through, on the second pass through of the code, that's when it actually executes the code itself. And so the reason why that's important is because here on line 4, I invoke a function called will this work, but I actually create the function on line 6 through 8. And the answer is when I invoke this is that this actually will work, because the point of what Java uses hoisting, what it does is it will hoist all the variables, not their values. It will hoist the variables to the top of the page, right? Hoist means to lift up. So it will lift up all the variables to the top of the page so that we know that the variables exist, but their values will be undefined until the second pass through. But more importantly, when we define functions with the function keyword like we do on line 6 through 8, during the first pass through, it will actually hoist a function up to the top of the page, and we'll be able to use that function anywhere else on the page, even if it comes quote unquote before the function declaration. And so here on this, looking at this page of code here on lines 4 through 8, on the first pass through, what JavaScript does is JavaScript goes to line 4 and says, okay, I need to run this, but I'll run this on my second pass through. Then it gets to line 6 through 8 and it'll say, oh great, here I'm creating a function. Let me hoist this to the top of the page so I can use it anywhere else on the page. And then it will go to the second run through of the code. And now when it gets to line 4, it will actually run the function, will this work? And it will know what to run because it has already hoisted this function. So that's why that's the reason why when we use a function declaration, we are able to invoke the function before we declared or before we quote unquote created in the code if we only read it from top down. The main use case or the main contrast for this is to say that if you create a function this way, aka if you store it in a variable like we do here with this variable, will this work? This will actually, I guess the console log kind of gives it away. It won't work because now on the first pass through, what JavaScript's going to say is JavaScript's going to say, oh great, there's this variable called will this work. Let me assign it the value of undefined, and then I'll give it a real value on the second pass through. Well, if it does that on the first pass through, it has a variable called undefined. On the second pass through, it hits line 4 first, and it tries to invoke that variable. Now, when it tries to invoke undefined, it will get back an error that we see here. It says, well, this work is not a function. And so this is, once again, something to just kind of keep in the back of your mind when you need to create a function is, do I want a function declaration or a function expression? I would say for our class, function declaration, so we saw in the previous slide, this will work universally when it comes to creating functions, and so I would kind of err towards using it this way as a rule of thumb. But if you do it this way, aka with a function expression, then just be careful of the order in which you're creating the functions and then also using the functions. Last but not least, we just have some scope best practices. Generally speaking, you should not use global scopes. They may seem really convenient, but the reason why we don't want to use global scopes is why we don't want to use global variables is because if you have a global variable, then that means anyone else can change it, and when you're using the value of the variable, you don't actually know what the value is anymore, right? It's kind of like having a password that everyone else knows. It kind of defeats the purpose. If I have a password, or let's say I have a bank account that anyone else has access to, well, I can't really withdraw from the bank account because I don't know who else has already withdrawn money from it or how much money is left. And that becomes like a problem actually in programming that we see quite often, which is that, hey, look, I have this variable. I want to make sure only certain people have access to it because I want to make sure that the value is preserved. And if the value is different than what I expect it to be, I know where to check on who used the value and kind of what they did to it. So it becomes really easy to create a paper trail for how the variable has changed over time. So as a general rule of thumb, always stay away from global variables. Your variables should be created in a way that it should only be able to be used where it should be used. So here I have this variable called always true as equal to true. The point here is that on lines 4 through 6, I create a function called don't mind me where I change the always true function to false. And I invoke it on line 8. Now when I get to line 10, I don't actually know what the value of always true is, right? Because if I look at line 2, I think, well, it's true, but line 4 through 6, it can actually be changing it, and I'm now aware that the variable got changed. And so once again, this is the reason why we don't want global variables to be used too often. Now, one way to get around this is to say, hey, look, if I'm in the don't mind me function, I need a variable called always true, I need it to be false. Well, let me just create my own local version of that variable. And now wherever inside this don't mind me function, if I want to use the always true variable, I'm only using and modifying my own local version, not the global version. But once again, this is more of like a way to circumvent something that hopefully doesn't really happen in the first place. And then the other reason why we don't want to use global variables is just because it just makes the global namespace very cluttery. If everyone wants to create their own version, if everyone wants to create their own global variable called X, well, you can imagine how messy that would get and how many conflicts there would be. And so, generally speaking, we want people to declare variables only inside functions or blocks, and less inside the global scope. So that was it for today. Are there any questions on anything I've covered regarding scope? Any questions before we stop?